Hello everyone. Today I'm going to solve two examples from Math 115 exam of University of Michigan, and these two examples are going to cover the concept of domain, and actually the first one is going to cover the concept of domain and zeros in a function, and the second one is going to just cover the concept of domain in a function. The first example that we have in here says, let a and b be positive constants. The rational function y equals to px is given by the following formula. Px equals to 5x times x minus 2 times ax plus 1 squared over 3x squared plus bx times x squared minus 9. And as I said, we want to find the zeros and domain of this function. So for finding the zeros of this function, what we have to do is we just need to look at the denominator in here, and we have to find basically the x in which this denominator is going to be 0. So we have to find the cases in which this denominator is 0. And for the domain, we have to find the value of x in which this function is going to be undefined, and therefore those x are going to be outside of the domain, and the rest of the x is basically the domain. So let's look at the first part and finding the zeros of this function. As I said, we have to look at this denominator, and it's going to be 5x times x minus 2 ax plus 1 squared, and roots of this is going to give us the answer in terms of zeros for the function. So if we look, there are three possibilities for this function to be 0. First, 5x equal to 0, then x minus 2 equals to 0, and the last one, ax plus 1 equals to 0. So for 5x equal to 0, it means when we plug in x equal to 0, this is going to be 0, therefore this multiplication is going to be 0 at the end. The second one is x minus 2 equal to 0, and from there we can say x equals to 2 would result in 0 for this denominator. And the last one is ax plus 1 squared, and ax plus 1 can be 0 only when x is minus 1 over a. Therefore, for three different x, this function can be 0, and these are basically zeros of this function. So there's three numbers. For the second part of this example, we have to find the domain of this function, and as I said, for this rational function, the best case is to look when this function is undefined, and if we find those x in which the function is undefined, we basically remove those x from the domain, and the rest of the x in the real numbers are going to be the domain of this function. And if we look in here, the denominator can be actually this function can be undefined only when this denominator is 0. Therefore, we can write 3x squared plus b times x squared minus 9 equal to 0. And if we look, this function, basically this part, can be only 0 when the first term is 0 or the second term is 0. So we have two different cases, and we have to investigate both cases in here. For the first case, 3x squared plus b equals to 0. We know this is always positive or at least 0, but the problem is saying that b is positive. Therefore, if it is a positive number, this part cannot be 0. So there is no x in here, which makes this a part of the function 0. But now it's time to look at the second part, which is x squared minus 9 equals to 0. And there are two possibilities, 2x, which can make this function 0. If we plug in x equal to 3 or minus 3, we can get 0 out of it. So x equals to positive and negative 3 is actually the answer for here. Which means that if we have x equals to positive 3 or negative 3, this function is going to be undefined. Therefore, the domain is any real number rather than x positive negative 3. Let's look at the second example that we have in here, and this example is again asking for the domain of this function. In order to find the domain of this function, again we use the same procedure because we are dealing with a rational function, and for the rational function we have to see, in general basically, we have to see for which x the function is undefined. Once we obtain that, we know that those x are going to be removed from the domain, and the rest of x in real numbers are basically the domain of that specific function. And in here, if we look at the denominator, at this denominator in here, we see the function is defined for any number. So it's time to look at the denominator again, and we have to see where this denominator is going to be 0, and from there we can understand this function is going to be undefined for those specific x, and basically we can say, okay, those x's are not inside the domain and the rest is the domain. So we do this, we set x plus 1 x minus s square root of 3 equals to 0, and this can be 0 only for two possibilities. The first one, x plus 1 equal to 0, and the second one, x minus the square root of 3 equal to 0, which means that once x is equal to minus 9, this is 0, and when x equals to a square root of 3, this is actually going to be at the end 0. So from here we can say, okay, if x equals to minus 1, the function rx is undefined. When x equals to a square root of 3, this function is undefined. Therefore, the domain is any real number rather than x equals to s is equal to minus 1, and when x is not equal to the square root of 3. So we can have any number rather than this 2 inside this function, and these are not inside the domain. Thank you very much for watching this video. Hope you enjoyed and learned how to find the domain and zeros of the function. I think we have had enough practice problems regarding the domain and zeros of the function, also inverse and range of the function, and I think at this time you should be fine with finding the domain, inverse of the function, zeros of the function, and range of the function. You can watch other videos on this topic, and if you enjoyed, again, please subscribe our channel.